need to expose user-specific data to your AI while keeping sensitive parameters hidden from the model itself. You'll see how to create a FastMCP tool that automatically excludes certain arguments from the AI's view, while still allowing the server to inject them at runtime. This pattern keeps credentials and identifiers secure, while giving your AI the functionality it needs. At MCP tool. Name equals get user details. Exclude args equals user ID. Def get user details, user ID. SDR equals none SDR. Hash userid will be injected by the server, not provided by the LLM. This demonstrates the parameter exclusion pattern in tool design, where certain function arguments are intentionally hidden from the client interface while remaining available to the server. The Decorator approach here creates a clean separation between public tool contracts and internal implementation details, allowing sensitive or context-specific parameters to be injected at runtime. The pattern works by declaratively marking specific parameters as excluded during tool registration. The framework then omits these from the generated schema while preserving them in the function signature, enabling the server to inject values like authentication tokens, user IDs, or session state automatically. This maintains a clean client-facing interface while supporting rich server-side functionality. This approach solves the common problem of exposing internal parameters to untrusted clients. It's particularly valuable in multi-tenant systems where tools need access to user context without requiring clients to provide it, or in security-sensitive applications where credentials must never be exposed. The trade-off is slightly reduced transparency, as clients can't see all parameters the tool actually uses. Let's break it down line by line. At MCP tool. Name equals get user details. The @MCP tool decorator registers this function as an AI callable tool in FastMCP. It transforms a Python function into a structured tool that AI models can discover and invoke, using the function's type hints and docstring to generate the tool schema. Exclude args equals user ID. This excludes userid from the tool's exposed parameters. The server injects this value at runtime, preventing the LLM from supplying or overriding it, which maintains security and data integrity. This closing parenthesis terminates the @MCP tool decorator declaration, finalizing the function's registration as an AI callable tool. Without it, Python would raise a syntax error, preventing the decorator from properly exposing this function to the FastMCP server. Def get user details, user ID. SDR equals none SDR. This defines the tool function with a default none parameter, making userid optional in the signature. The server injects the actual userid at runtime, so the LLM never provides it directly, ensuring controlled access to user data. The SDR return type hint documents the expected output format for the AI caller. Hash userid will be injected by the server, not provided by the LLM. This comment clarifies the security boundary. The server injects userid at runtime, preventing AI models from spoofing or overriding user context. Critical for multi-tenant systems where user isolation must be enforced by the framework, not trusted input. Tool argument control pattern. The exclude args parameter in FastMCP tool decorators creates a deliberate separation between server-managed parameters and LLM-provided arguments, enabling secure injection of context without exposing implementation details. Arguments marked for exclusion still appear in your function signature, but vanish from the tool's schema, creating a silent contract between server and client. This pattern lets you build tools that adapt to runtime context while maintaining clean, focused interfaces for AI clients.
The argument that disappears from the schema becomes the argument that connects everything.